Hello students, welcome back to Husky Math. This is the second part of our 9 special integrals where we will be discussing the second set of 3 integrals. So today we will be discussing the next set of 3 integrals. In previous 3 formulas, there were no square root. So it is very similar to the previous 3, okay? Just the formula are different. But the way we have to deal with the question is same. Question 1. Evaluate 3x square over square root of 9 minus 16x to the power 6 dx. Here we cannot directly apply the formula because in the formula the numerator is 1, but here the numerator is 3x square. So let us assume x cubed to be t at first here. So let us put x cubed to be t. And on differentiating we will have 3x square dx equals to dt. Therefore, the integral I will be equal to 3x square dx is dt over square root of 9 minus 16. Since x cube is t, therefore x to the power 6 is t square. And here we have to notice in formula that the coefficient of x squares are always 1. So since there is 16 in front of t square, so we will take out 16 common from here. So we will have dt over square root of 16, taking out common, then I will have 9 over 16 minus t square equals to integration of dt over, let us write square root of 16 separately, then we will have square root of 9 over 16 is 3 by 4 whole square minus t square equals to 1 over square root of 16 is 4 and which is constant dt over square root of 3 by 4 whole square minus t square. Now this is in the form of this third formula where a is 3 over 4 and x is my t. So using the formula here, I will have sine inverse of x by a, that is sine inverse of t by a plus c equals to 1 over 4 into sine inverse of 4t by 3, putting back the value of t, we will have 4x cube by 3 plus c. Question 2. Integration of dx over 1 plus 4x square. So first let us take out 4 common from denominator, then we will have dx over square root of 4 common, then 1 by 4 plus x square, and taking out square root of 4 constant, dx over square root of 1 over 4 is 1 by 2 whole square plus x square. Now this is in the form of this first formula, so it equals to 1 over square root of 4 is 2 into log of x plus square root of x square plus a square, that is 1 by 2 whole square plus c equals to 1 over 2 into log of x plus square root of x square plus 1 by 4 plus c. So you can leave your answer at this point because this has been integrated, simplified further. 1 by 2 log of x plus, taking LCM here inside, then we will have 4x square plus 1 over 4 plus c. So it equals to 1 over 2 log of x plus square root of 4x square plus 1 and square root of 4 is 2 plus c, and again adding the terms inside the log, we will have 2x plus square root of 4x square plus 1 whole divided by 2 plus c. Since we know that log of a over b is log of a minus log of b. So using that property of log, we can write this as log of a, that is minus log of b, that is log of 2, plus c. So it equals to, opening the bracket, we will have 1 by 2 log of 2x plus square root of 4x square plus 1 minus half into log of 2 plus c. And since minus 1 by 2 log 2 is also a constant plus the constant of integration has been written simply c only. So you can find some answers to be like this. Question number 3. Evaluate dx over square root of x square plus 6x plus 5. Now this is in the form of 1 over square root of a quadratic equation. So just like in previous video, here also we will try to make this quadratic equation into the sum or difference of a perfect squares. For that, at first we have to see whether the coefficient of x square is 1 or not. So here the coefficient of x square is already 1, so that's good. And after that we have to observe the coefficient of x, which is 6 here, and we have to multiply this 6 with half. On doing so, we will get 3. So what we will do is that we will add and subtract the square of this 3. So it equals to integration of dx over square root of x square plus 6x is there, and after that let us add 3 square and subtract 3 square plus 5. Now these 3 terms can be written as x plus 3 whole square. So it equals to integration of dx over square root of x plus 3 whole square, and simplifying the 2 terms we will have minus 4 equals to integration of dx over square root of x plus 3 whole square minus 2 square. Now this is in the form of this second formula here, but instead of x there is x plus 3, which is a linear polynomial, so we can directly apply the formula. So applying the formula, we can write this as log of x, that is x plus 3 here, plus square root of x square minus a square, that is x plus 3 whole square minus 2 square plus c. So this equals to log of x plus 3 plus, now if we simplify the term inside this square root, then you see this term was actually x plus 3 whole square minus 2 square, which was x plus 3 whole square minus 4, and this we got from this step. And finally, if I simplify this, we will get back the quadratic given in question, that is x square plus 6x plus 5. So here if I simplify this x plus 3 whole square minus 2 square, we will get back to the question only. So we will just write x square plus 6x plus 5 plus c. So don't waste your time by just opening this a plus b whole square and simplifying, because if you do that also you will get the same thing like in the original function. Question 4. Evaluate dx over square root of 8 minus 4x minus 2x square. So here as you see, there is the coefficient of x square is minus 2. So we will take out this 2 first to make the coefficient of x square 1. But note that we will not take out minus 2 common, because since this everything is inside the square root, and if I take out minus common from the square root, then it will be an imaginary number. So just take out 2 from the denominator. So this equals to integration of dx over square root of, taking out 2 common, I will have 4 minus 2x minus x square. So the coefficient of x square is 1 here now, equals to, taking out square root of 2 as constant, integration of dx over square root of 4 minus 2x minus x square. Now again this is in the form of 1 over square root of quadratic. So here the coefficient of x is 2. So multiplying this 2 with 1 by 2, we will have 1. That means we will add and subtract the square of 1. So it equals to 1 over square root of 2 integration of dx over square root of 4, adding 1 square and subtracting 1 square and writing minus 2x minus x square, equals to 1 by square root of 2 integration of dx over 4 plus 1 square is 1. Now taking out minus common from here, we will have 1 square plus 2x plus x square equals to 1 over root 2 integration of dx over square root of 4 plus 1 is 5 minus this everything is x plus 1 whole square or 1 plus x whole square, but I prefer to write x first. And here the 5 can be written as square root of 5 whole square minus x plus 1 whole square. Now this is in the form of the third formula here, that is integration of dx over a square minus x square. So using the formula there, we will have sine inverse of x by a, that is x plus 1 over root 5 plus constant of integration. Question 5. Integration of dx over square root of x into square root of 5 minus x. So here we will just first multiply this x and 5 minus x. So then we will have square root of x into 5 minus x equals to integration of dx over square root of 5x minus x square. Now again this is of the same type, so here we will look the coefficient of x, which is 5, and we will multiply 5 with 1 by 2, which will give 5 over 2. So we will add and subtract the square of 5 over 2 equals to integration of dx over square root of 5 by 2 whole square minus 5 by 2 whole square plus 5x minus x square equals to integration of dx over square root of 5 by 2 whole square, taking out minus common, then we will have 5 by 2 whole square minus 5x plus x square equals to integration of dx over square root of 5 over 2 whole square minus, this can be written as a minus b whole square. So either you can write 5 by 2 minus x whole square or x minus 5 by 2 whole square, but I prefer to write x first minus 5 by 2 whole square. Now again this is in the form of this third formula. So using the formula, we will have sine inverse of x by a plus c. Simplifying, we will have 2x minus 5 by 2, and that 2 will get cancelled with the 2 below 5. Question 6. Evaluate 2x plus 3 over square root of x square plus x plus 1. So this is in the form of linear over square root of quadratic, and the rule is same as before. So here we will try to split this linear polynomial which is at the numerator into two terms, and we will split this integral into two parts. For that, the rule is we have to assume the linear polynomial equals to a into the derivative of denominator plus b. So using the rule here, we will first put numerator, that is 2x plus 3 equals to any number a into ddx of denominator, that is x square plus x plus 1, but skip the square root, okay, plus b. So this implies 2x plus 3 equals to a into the derivative of x square is 2x and derivative of x is 1 plus b. So 2x plus 3 equals to 2ax plus a plus b. Now at this point we have to compare the coefficient of x on the both sides. So here we will have 2a equals to 2, which gives a equals to 1, and the constant terms, that is a plus b equals to 3. A plus b equals to 3, but since a is equal to 1, so 1 plus b equals to 3, which gives b equals to 2. Now we will put the value of a and b in this equation. So we can write 2x plus 3 equals to 1 into 2x plus 1 plus the value of b is 2. So we just splitted our numerator into two terms. Now we will write 2x plus 3 as 2x plus 1 plus 2. Therefore, integral I is equal to 2x plus 3 can be written as 2x plus 1 plus 2 whole divided by square root of x square plus x plus 1 dx. Now we will split the integral into two terms, that is 2x plus 1 and 2, separating the denominator. So it will be integration of 2x plus 1 divided by square root of x square plus x plus 1 dx plus integration of 2 over square root of x square plus x plus 1 dx. Now for the first term, that is this one, we will assume x square plus x plus 1 to be t. On doing so and differentiating, we will have 2x plus 1 dx equals to dt. Therefore, my integral I will be equal to integration of 2x plus 1 dx is dt, and there is a square root of t. So this is for the first part. And for the second part, that is, so for this part we have to make the denominator the sum or difference of the perfect squares. So here it will be plus, since 2 is constant, integration of dx over square root of x square plus x, and since coefficient of x is 1 here, so we will multiply 1 with 1 by 2, which will give 1 by 2, and we will add and subtract the square of 1 by 2. So here adding 1 by 2 whole square and subtracting 1 by 2 whole square, plus 1 is at last. So this equals to integration of square root of t is t to the power minus half dt plus 2 into integration of dx over this, everything is x plus half whole square, and on simplifying these two terms plus 3 by 4 equals to integration of t to the power n is t to the power n plus 1 over n plus 1 plus 2 into integration of dx over square root of x plus half whole square plus square root of 3 by 2 whole square, because square root of 3 whole square is 3 and 2 square is 4. Now the second part of integral is in the form of x square plus a square, for which we have the formula equals to t to the power half by half plus 2 into, using the formula here, we will have log of x, that is x plus 1 by 2, plus square root of x square plus a square plus c. So here it will be the inverse of 1 by 2 is 2, putting back the value of t, that is our quadratic, x square plus x plus 1, and since there is to the power half, we can write this as square root plus 2 log of x plus 1 by 2 plus, now if I simplify this expression, then we will get x square plus x plus 1 only. Because we have been modifying the same quadratic expression in the sum and difference of our perfect squares. So this is the answer for this question. Question 7. Integration of x plus 2 over square root of x square plus 5x plus 6 dx. So this is the same form of linear over square root of quadratic. So here also we try to split the numerator into two terms and eventually split the integral into two parts. So following the rule, let us put x plus 2 equals to a into d dx of the quadratic expression on the square root plus b, implies x plus 2 equals to a into 2x plus 5 plus b. So x plus 2 equals to 2ax plus 5a plus b. So comparing the coefficients of x, we will have 2a equals to 1, which will give a as 1 by 2, and comparing the constant terms, we have 5a plus b equals to 2, putting the value of a gives b equals to 2 minus 5 by 2, which will give b equals to minus 1 by 2. Therefore, x plus 2 equals to, let us put the values in this equation, 1 by 2 into 2x plus 5, and the value of b is minus 1 by 2. Therefore, I equals to integration of 1 by 2 2x plus 5 minus 1 by 2 whole divided by square root of x square plus 5x plus 6 dx. So splitting the integral, we have 1 by 2 is constant, integration of 2x plus 5 square root of x square plus 5x plus 6 dx minus 1 by 2 is constant, dx over square root of x square plus 5x plus 6. So in the first part we will assume x square plus 5x plus 6 into t, and in the second part we will make this denominator the sum or difference of a perfect squares. So for the first part, let us put x square plus 5x plus 6 equals to t, which gives 2x plus 5 dx equals to dt. So I equals to half integration of dt over square root of t minus the second integral where there is x square plus 5x, and since the coefficient of x is 5, so 5 into 1 by 2 is 5 by 2, so we will add and subtract the square of 5 by 2, and there is 6 at last, equals to 1 by 2. So integration of 1 by root t is 2 into root t minus 1 by 2 integration of dx over, these three terms collectively can be written as x plus 5 by 2 whole square, and if we simplify these two terms, then we will have minus 1 by 4. So here 2 and 2 got cancelled, equals to, putting back the value of t, we have x square plus 5x plus 6 minus 1 by 2 integration of dx over square root of x plus 5 by 2 whole square minus 1 by 4 is 1 by 2 square. Now this is in the form of 1 by square root of x square minus a square. So we will use the formula there, which is the second formula for today. So the formula for it is log of x plus square root of x square minus a square plus c. So the final answer will be x square plus 5x plus 6 minus 1 by 2 log of x plus 5 by 2 plus square root of, if we simplify this, then we will get back the same thing, that is x square plus 5x plus 6 plus c. So with this we came to an end of this second part of 9 special integrals. I hope you are understanding the solutions. So in the next video we will be discussing the last 3 special integrals. So till then, keep practicing. Bye bye.